So, remember my programming language Chrono. This is Chrono. It's a general purpose programming language made for modern programming. I made it because I was tired of C# being so dependent on .NET. And right now I'm rewriting the code generator to make a custom backend for Chrono. Yeah, that's exactly what I did. If you're just landing here, my name is Next and I'm the creator of the Chrono programming language. So 2 videos ago, I wanted to create my own language backend because the LLVM C API wasn't so flexible with Zig bindings. And for that, I created my own custom language backend called Envy. Envy is a new language backend with x86-like intermediate representation, initially tailored for Chrono. Why the name Envy? Well, it's the edition label of my laptop and sounds cool. The first goal for the backend was to display text on screen in different targets, primarily 32-bit and 64-bit Linux. So, let me guide you through it. Before anything, I needed to design the intermediate representation to something that wasn't too high level, so it doesn't have a lot of abstraction, and not so low level that parsing to different assembly dialects was complicated. And then I had the idea, why not just make it like assembly? Contradictory, right? But hear me out. What if I had an intermediate representation that was just like assembly, but with just enough generic instructions that could translate to every other instruction in other assembly versions? That was my thinking process. So I started to write x86 assembly in a blank file and started adding new instructions that could only do one thing. By the way, apparently this version of assembly is very criticized for having many implicit behaviors, so I'll try to avoid that. Eventually, I started to make up some instructions like define, variable, assign, function, pass argument, and many others. With that out of the way, I still needed to parse the intermediate representation and turn it into useful information. So, just like Chrono, I did the tokenization process, created an AST, parsed the tokens, turned those tokens into AST nodes, and finally transversed the AST. Plus, I added a translation layer between Chrono and the intermediate representation. It was a lot easier to parse this one because it had fewer instructions and stuff to parse in general. Moving on to code generation, I made another translation layer to generate 32-bit assembly based on the AST information, and it was confusing. The prototype for the translation layer was only working for one specific use case. It had a lot of spaghetti code and the compilation pipeline was becoming a nightmare. Envy is a sub-project in the Chrono compiler project, so you can imagine the hassle of debugging both projects at the same time to make something work. So I did some janitor work to keep the pipeline clean and even made a build mechanism to help me compile the code more autonomously. For the task of printing text to the screen, I wanted to use a hard-coded print function, not libsys, but my own implementation of it, which is really just a few lines of assembly. So I introduced a new keyword and instruction called extern, updated both projects to support it, and after many segfaults and skill issues, I managed to get text on screen. And to make things a lot easier, the build mechanism works by placing the output file in a single file, having a root file calling the main function, and have a very minimal standard library containing the print function plus other functions. With that out of the way, you'd assume that I only had to change the value target to 64-bit and made another translation layer and the video will be over, right? Well, yeah, but then, would you be satisfied? Would Chrono really be something worth checking out over some printed text? I don't think so. Then I have a list of to-dos still worth giving a shot for this video, like update the CLI to have compiling options, modularize the target base code, make a basic KPI for Envy, and a bonus. For the CLI, I added a new parameter to the CLI to specify the compilation target before passing the file, and organize the translation layers to each one generate the right code to their targets. For the API, I used the prototype translation layer as base to create a proper API with more generic options and created a new struct that will specify the type of data that will be passed to the instructions. As bonus, I added another system call, read. For the readline function, I did the same thing with print. I hard-coded the function in the standard library file and tried calling the function expecting it to fail, and it did. That was due to some parsing issues I didn't fix in both the Chrono parser and the Envy parser, so I fixed those, and while I did that, I realized I needed to fix some other things, like the variable declaration instruction was modified into this version. I wanted something more elegant, and it also made it a lot easier knowing the type with the size inferred. Native types such as signed and unsigned integers from 8-bit to 64-bit will be supported. As for strings and more complex data types, it will be based on structs. Structs in assembly is just memory laid in a special way, in such way that is accessible by using the pointer to the struct and an offset to access the fields. Strings in general are structs that have the following layout. This in assembly will be. This makes accessing string values more easy, because now when you initially point at a variable containing a string, you get the length of the string, and just 4 bytes ahead you get the buffer. That allows us to make some interesting stuff and levels up the game, because now Chrono is slowly implementing the concept of structs, just at a lower level. Also, it allowed me to make the print and readline functions to follow some type of standard. You might also notice that I'm doing a lot of work in 32-bit Linux target, and that is because the assembly course I took taught me 32-bit Linux assembly and not 64-bit assembly. Not so convenient, I know. There's still a lot of stuff to cover and work to do, but the video is already getting a bit too long, so I'll make a part 2 to cover other parts of the project and things like structures, 64-bit assembly, and other stuff I left aside. If you want to check out the project and keep an eye on how things are going, you can check out the project in GitLab. The repository link will be in the description. Also, you can follow me on Blue Sky for snippets and video announcements. By the way, I can't help but thank you all for the amazing support. The last video went crazy and got recommended a lot. Even got to chat with a lot of you in the comments. We're this close to making it to 100 subscribers, so don't forget to leave a like and subscribe, and see you next time.